Let's start geometrical optics. Till now we have studied only in class 12. If you think what we have studied, actually we have studied electromagnetism, right? In each and every chapter, either we have studied electricity, or you have studied magnetism, or we have studied the combined effect of electricity and magnetism. Basically, this entire 12 is only the discussion of electromagnetism, because optics that we are now discussing also one type of electromagnetic wave, right, that we will discuss in later part. But today in this first lecture, optics is actually divided into two parts. One is geometrical optics, another is wave optics, right? Geometrical optics is the earliest form of optics. Earliest means when the theories of optics were just developed, people used to take light as a rays. Right? Rays means they said that light travels in a straight line. If nothing is changing, medium is not changing, you do not hinder that path, then light is always moving in a straight line, and those are straight lines they named as light rays. And interestingly, most of the physical phenomena that light showed could be explained by those ray properties. So today in this class, not today, we will take 4 to 5 classes on this geometrical optics. We'll try to explain how this light rays, how we can explain the different phenomena of light by this light rays. But you have to understand that not all the phenomena of light can be explained by this light rays, right? So other properties, I mean, where there is some interference, diffraction, Compton effect, right, or some photoelectric effects, different effects of lights are there. We will discuss them one by one as our syllabus progresses. When we see that only the discussion of light as rays will not be sufficient to analyze all those experiments. But here in this chapter, we will discuss light as only rays. That is why it is known as geometrical optics. We use simple geometry to solve different properties. So first of all, we should understand few important properties of light rays. Look, I have written that geometrical optics is a very simplified approach to optical phenomenon where we assume light is collection of rays. This assumption is useful in practice when the wavelength of light can be neglected in comparison to the dimensions of the instruments used. That means if you are using a mirror, a normal mirror, right, that has a radius which is much higher than the wavelength of light. And a visible light ray, if you say, for a visible light, the wavelength will be in order of 10 power minus 5 centimeter or like that, right, 10 power minus 7 centimeter like that. So that is very much negligible in compared to the radius of that particular mirror. Or if you are using a lens, also you can neglect the wavelength of the light in compared to the dimensions of those lenses, right? So in that case, we can use light rays, and we can say that exceptionally they are a good approximations, right, to analyze the behavior of that light. Before that, we should take this 4 as my assumption in light rays. The first property of light ray, these are property, but you can also say these are assumption made by different various properties. When we analyze, we have concluded that these 4 properties should be there in a light ray. The first property is in a homogeneous medium, light ray travels in a straight line, right? So when the medium is homogeneous, that means there is no change in medium, right? So when light is traveling, suppose in a straight line, the light was traveling in a straight line like this, and if you do not hinder it, if you do not change the medium, it will continue that motion in the straight line. But suppose suddenly you have changed the medium from air to water, right, then the light will bend its path by certain amount, right? So in a homogeneous medium, light always travels in a straight line. This is the first property of light. Second property, when two light rays intersect, they do not interfere, right? So if the one light ray was propagating in this direction, another light ray was propagating in this direction, they will propagate as if there is no interaction at the point where they meet, right? This is the property of light ray, but it is not possible in case of light wave. If you remember, in case of waves, when they meet, they interfere, right? The waves they meet, they interfere, and the resultant displacement of that interference point is the summation of the actual individual displacements. That you should remember from the interference
স্যার
of
এখানে
waves.
তো কোনো মিরর নেই, তাহলে এখানে আমরা কেন লাইট কে রে হিসাবে ট্রিট করছি, কেন ওয়েভ হিসাবে নয়?
এখানে কোনো no, I'm talking about some experiments where there we are considering this situation. Suppose there was a mirror here, light ray traveling from here to here. There is a mirror here, light rays traveling from here to here. So in that case, you can say that. Right? It's not that everywhere you will find a mirror. It may be a lens, it may be a refracting surface. All of them you can neglect the wavelength of light compared to the dimensions of those.
রেজাল্টিং ওয়েভ ফর্ম হবে না?
No, I am not studying the waves nature of light here. I am studying only the ray property here. Right? Yes, there is a.
What is the difference between rays and rays?
Look, rays is not a ray is not a not something that you can say that light is a ray. Light is not a ray. You have to understand this thing clearly, that ray is a method to explain few properties of light. In geometrical optics, we are not concerned about what is light. Right? If you ask me what is light, is this a ray? That is not a valid statement.
The particle nature of light.
Again, I am saying, try to listen my statement first. In geometrical optics, we are not concerned about what is light. Is it a particle or is it a wave? That is a different argument. That is a separate class lecture that we will study all those things. Dual nature of light. Ray optics is a method. Ray optics is a method to understand different properties of light. That's all. You cannot argue what is there inside that ray. Inside that ray, is there a wave? Inside a ray, is there are particles? Inside the ray, what is there? You cannot argue that. That is only a method to solve light phenomena. Right? So ray optics is only a assumption and method. What is light? That has a different argument. Light may behave as a particle or light may behave as a wave. Right? But light ray, you cannot say whether it is a particle or a wave. It is only a method that we have to understand. That different phenomena can be explained by this light rays. Right? Because whatever, you cannot see light ray. Can you see light ray? No. This is an invisible thing that helps us explaining few properties of light. Have you understood? So this question that whether light is a particle or wave is not valid for this chapter. You preserve this question for other chapters. Definitely we will discuss what is light. Right? So if you ask me, then the phenomena like reflection in a mirror, refraction in a water surface. Can those phenomena be also explained by wave nature? Yes, I can say those properties can also be explained by wave nature of light. Few properties can also be explained by particle nature of light, right? But all the properties can be explained by the light rays. I'm not, again, my statement is incorrect that I am not going to explain those properties but by light rays. I am going to analyze those properties by light rays. Right? I'm not going to find the reason behind that. Why the reflection is occurring? Why the refraction is occurring? I'm not going to find the reason behind that. I'm going to analyze that phenomenon by ray optics. Have you understood what I have tried to say?
Yes, sir.
Yes, sir. All right. So now there are few assumptions of light rays that I have made. The first two assumptions I have explained. The third assumption is law of reversibility of light ray. Suppose a light ray was moving in a straight line like this, and you bent that light ray such that the path is reversed, right? So suppose the light ray was bent here like this. Now here if I just reverse that light ray, you will find that after reversal the light ray will follow the same path, right? It is known as law of reversibility of light ray. After reversal the light ray will follow the same path, right? Law of reversibility of light ray. When it is reversed, it retraces its path, right? And fourth property is also known as Fermat's principle, that says when a light ray has to travel in between two given points, suppose light ray has to travel in between these 2 points A and B. Following this mirror, then there are infinite number of ways light ray can travel from A to B following this mirror, right? You cannot say directly it connect A to B, then there is no role of the mirror, right? So if a light ray has to travel from A to B following the mirror, then out of all those paths you have to choose that path which will take the light ray in a minimum time. That is by pure observation, right? By Fermat, and he made that statement: light ray follows that path, will follow that path that takes the minimum time to reach from one given point to another given point, right?
We did not do any mathematics for getting this.
You can prove Fermat's principle if you apply some other rules of light. Law of reflection you use, you follow, you can prove Fermat's principle. But we will do reverse. We will apply Fermat's principle and we will try to prove the law of reflection. Right? We will apply Fermat's principle and we will try to find the law of refraction.
স্যার আপনি তো বললেন এগুলো সব অ্যাজিউম করে না, তাহলে তো এগুলো কোনোটারই তো প্রুফ করা যাবে না বলো?
No, this is pure observation based, right? So you can prove one assuming another. As I have told you, if you assume the law of reflection to be correct, you can prove Fermat's principle. Or if you assume Fermat's principle to be correct, you can prove the laws of reflection.
But did Fermat prove it?
Yes, by observation you can prove it. Not Fermat proved it, he observed this thing happened. Right? But nowadays, if you want to prove it, you can prove it, right? Because we have precise instruments to measure the time taken for the light to travel from A to B, and you can prove it also. theoretical.
Time, so the time that we pay for, so it will be measured.
I could not get your question. What's your question?
So the time the light will take to travel in different paths, the time will be very small. So can that
Yes,
be
yes.
measured?
Yes, as I have told you that nowadays very precise instruments are there. You can measure, right? You can definitely measure. Are all these properties of light clear to us?
Yes, sir.
Yes, sir.
Okay, now we will move to the laws of reflection. As we
Sir,
know, yes,
sir, you have told that the light ray is imaginary concept.
yes, yes.
Sir, then how can we measure the time of the light ray?
How can we
Measure the time of that light ray.
measure what?
Sir, how can you told that we can measure the time to
Time, yes,
of a light ray after reflection.
yes,
So then how can we measure? It is imaginary concept.
yes. That look, light rays are imaginary, but the properties of light you can always see. Suppose you have a torchlight here, right? So that torchlight will produce a light ray. You cannot see that light ray, it is an imaginary thing. You cannot see a light ray, right? It may be that torchlight is producing some wave. It may be that torchlight is producing some particles. We are not bothering about that. And after reflection, here the reflection is occurring. So it may be after reflection some wave is generated. It may be that after reflection some particles are generated. Whatever it may be. But if you have a screen here, will you see a spot on the screen?
Okay, sir, got it. Yes.
Right? So I will measure the time from switching on that this torchlight to the this spot appearance on the screen. That time you can measure.
So that means we are not bothering about the light.
No, we are not bothering about the phenomenon which is progressing. We can analyze the situation by simply light rays.
Yes.
Right?
Got it.
As soon as the dimensions of the measuring instruments are large enough. Okay, so now we will talk about property of light rays. Properties of light rays means the reflections. So these are laws of reflection. These are not properties of light rays. I have just made a copy paste. That's why the problem is. These are laws of reflection, right? Laws of reflection. We all know that laws of reflection. Incident ray, reflected ray, and normal at the point of incident ray lie on the same plane, and the angle of incidence and angle of reflections are the same. And it is not only true for a plane mirror. Even if you have a any curved surface like this, suppose you have a shiny surface like this. So if light ray falls at this point, also you will find that laws of reflections are valid, right? Also, if light ray falls on this plane, laws of reflections are valid everywhere, right? So you can see this is the normal, this is the incident ray, this is the reflected ray, and the angle of incidence and angle of reflections made with the normal. We always calculate the angles made with the normal. They are always the same. It is the law of reflection. Right? Very simple thing. And we can also prove this law by Fermat's principle, the application of Fermat's principle. Right? So what is that proof? It goes like that. Or also we will actually prove that Fermat's principle from laws of reflection. Whatever you can say, we can do it. Right? If we assume reflections are correct, laws of reflections are correct, you can prove Fermat's principle. Suppose I have a mirror like this, right? Suppose I have a mirror like this, and a light ray is coming in this path. Light ray is coming in this path. So after reflection, the light ray moves to the point B. Point B may be anywhere, right? There are two possibilities of this light ray to move from A to B. One way is that it follows the laws of reflection, where I can assume that this is the normal, where I can assume this angle of incidence and angle of reflections are same. Another path, I will assume any general path. Any general path, you can take this point also here. Any general path where these two angles are not the same. Now I have to prove that out of these two paths, one is this yellow colored path, another is that red colored path. Out of these two paths, this yellow colored path will take minimum time to move from A to B. Right? For that, what I will do, I will drop a perpendicular from A to the mirror. Right? It is the mirror. You can see it is the mirror surface. So I will drop a perpendicular from A to the mirror, and I will extend that perpendicular by the same amount in order to find a image. Right? I will drop the perpendicular by the same amount, and I will join this point with this point. Right? I will join this point with this point. Also, I will join this point with this point. Now, look what happens as soon as I have dropped perpendicular. Suppose this is N, this is O, this is A prime, and this is M. If laws of reflections are true here in this light ray, I have to assume this angle is theta and this angle is also theta. Right? So, if in these two triangles, I can say this angle is 90 degree, this angle is 90 degree, this is the common side, and these two sides are also same. Can I say that then this angle and this angle are also same?
Yes.
Right? If this angle is phi, this angle is also phi. Right? Now, what is phi? Can I say phi is equal to 90 degree minus theta?
Yes, sir.
Phi is equal to 90 minus theta. So, what is that 2 theta plus 2 phi? Is it pi or not? If 2 theta plus 2 phi is a pi, can I say that A and B is nothing but a straight line? A prime and B is a straight line. So can I say it is a triangle A prime BM, and in this triangle the addition of two sides A prime M plus NB should be greater than A prime B? Now, as I have drawn these two triangles, can you say these two triangles are also similar? AOM and A prime OM?
Yes.
Right?
Yes, sir.
So, these two sides are also same, as well as these two sides are also same. So, from the triangles, I can replace A prime M by AM plus NB is greater than A prime B is A prime N plus NB, and instead of A prime N, I will write AN plus NB. Now look, as the velocity of the light ray is the same in this medium, this is only one medium, right? No medium change is there. So if I divide it with the velocity of light, can I find that time in the red color path is greater than time in the yellow color path?
Yes.
Right? So that is why you can say I have taken this any arbitrary point. So out of all the infinite number of arbitrary points, only this is the possible case where the light ray can travel in a minimum time. Right? So that is nothing but the Fermat's principle.
So can you explain the last 2 lines of the
Which one?
second last line?
This one.
Okay.
AM plus NB is the path to travel to A to B by this red color line, and AN plus NB is the path to travel from A to B by this blue color line. If I divide the path length with the speed of light, which is a constant everywhere in this medium, can I find the time? So time for this red color path is greater than time for this yellow color path.
Okay, sir. So that white line will not equal with some other line.
Yes, I could not get you.
So the white length of the white line will not equal with some line. Which line?
White line.
Yes,
You are talking about this yellow line, or this white line is a mirror.
the white line. So you have marked its length equal with some. From
Your
the
voice is not coming properly.
Yes, I cannot hear you clearly.
from the left side, you have marked the length of white line equal to the lines of which line?
Uh, this line, this A prime n is equal to A n, I have told.
attached আছে white side
So line ON.
Line ON, yes.
That length is equal with the length of which line?
ON is equal to which line? ON, I have not used the length ON anywhere.
না আসলে আপনি মার্ক করে দিয়েছেন ভুল করে ওএনটাকে।
ON টাকে মার্ক করেছি। আচ্ছা 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 আচ্ছা।
না তাই জন্য জিজ্ঞেস করছি।
Okay, okay, okay. Yes. This should not be there, yes.
এখন লাস্ট থার্ড লাইনটা বলুন।
I have said আমি ON টাকে মার্ক করেছি এই জন্য because I have said that in these two triangles AON and A prime ON, this ON side is common to both. ON side is common to both. These angles are 90 degree, and this AO is equal to A prime O. Right? So side angle side. Do you remember these two triangles are now the same triangle?
Congruent.
Yes. So that is why I have said that these two side lengths will also be the same. Same triangles means congruent triangles, and this angle too will be also the same. Okay. Yes. Now reflections on plane mirror, we will solve few questions on it. Like this question you can take, that a square frame is made by 4 plane mirrors. These are the 4 plane mirrors you can see, and a light ray is emitted from the midpoint of the point line AB. After 2 reflections, it comes back to point B. Find the angle tan theta. Let us first draw that rectangle, that square. Okay. Suppose this is a square. This is the square, and it
স্যার
is
tan থিটাটা ইনফিনিটি চলে আসছে।
okay. Let us check. So I have a light ray that first hits this wall. After two reflection means after that it hits this wall, and after one this reflection it
Sir?
comes back here. Yes.
Sir, cot inverse 3/4.
স্যার এটা উপরে হিট করবে না?
কোথায় হিট করবে আমার জানা নেই, বাট
Sir?
হ্যাঁ বলো বলো।
বলছি স্যার cot inverse 3/4 হবে?
3/4.
That may be the answer. Yes, that may be the answer. Something like this diagram can you make? Yes or no?
Yes, sir.
Yes. So if I say this is the initial light ray, then it hits here, then it comes back here, right? So this is B, this is A, this is D, this is C. Suppose this point is P, this point is Q, this point is R. If this angle is theta, let us assume this is X, this is Y, right? So let us assume the side length is 2A, right? So this length is 2A minus Y, 2A minus Y.
The side length can be 2x.
Side length can be 2x. You can say that 2x because it is the midpoint. So side length can be 2x. So it is 2x minus Y, and this angle is theta, right? So this angle is also theta. This angle is also
tan theta 4/3 হবে?
And this angle is also theta.
Sir?
Yes. Here is also one reflection is there. So this angle is also theta. Right? This side is 2x. So I can say if this length is L, this length will be 2x minus L. Right? So look, from this side I can say tan theta is equal to, from this triangle QDR, tan theta is equal to 2x minus y divided by L, and from this triangle RCB I can say tan theta is equal to 2x by 2x minus L. I can equate this two, and I can say 2x minus y by L is equal to 2x by 2x minus L. If you multiply, you will get 4x square minus 2xy minus 2xl plus ly is equal to 2xl. Right? Have I got it correct? If this angle is theta, this angle will also be theta. So tan theta is 2x by 2x minus L. And from here also you can say tan theta is equal to 2x minus y. If this is x, this is y. This is 2x minus y divided by L. And also from this triangle AQP, I can say tan theta is equal to y by x. Right? So I have to find the value of y by x. I can eliminate L actually. I can eliminate L from these two equations. Right. How do I eliminate L? It's not needed. I can eliminate L. L is equal to, from this first expression, L is equal to 2x minus y by tan theta. And in the second equation, L is equal to 2x minus L is equal to 2x by tan theta. So L is equal to 2x minus 2x by tan theta. Yes or no? Now I have got a relation of x and y, and I can just find the ratio of x and y and x will find the tan theta. right? So we can say that tan theta into 2x tan theta 2x tan theta minus 2x into tan theta okay, let us put the value of tan theta there. Calculation is becoming some lengthy. 2x minus y by tan theta is y by x is equal to 2x minus 2x by tan theta is y by x. So y I can cancel out, so it is 2x square minus xy is equal to 2xy minus 2x square. So 4x square is equal to 3xy. X gets cancelled out, I can find what is y by x is equal to 4 by 3. That is nothing but tan theta. That is your answer. Have you got it? Mathematical calculation is there, right? But not any other value you can directly find, right? 1 or 2, you cannot find this. It's a simple calculation you can find directly from there. Okay. And now we can find what is image tracing. How do I trace the image? Image tracing is very simple. Image tracing. Can you tell me how do I trace image? Image tracing on a mirror. Yes.
স্যার একটা হেড থেকে একটা লাইট পেয়ে আর একটা ফুট থেকে লাইট পেয়ে নিই
Image tracing. If I only ask you to find the image, that is a old method, right? You can do it definitely, but it will take some time. So suppose this is the mirror. Suppose this is the mirror, and we have a object here. We have a object here. So where the image of the object will lie? Very simple. Drop perpendicular from object to the mirror, right? Drop a perpendicular from the object to the mirror. Extend by the same amount, you will find the image. Yes or no? Can I say that? So image tracing means drop perpendicular from object to mirror and extend by the same amount, by the same length. You will find image. Right? Now if I ask you what is field of view, means can I see the image from here? Can I see the image from here? If I place my eye here, can I see the image? So what is the range where if I place my eye, I can see the image? Can you tell me how do I find that?
ইমেজ একটু মিররের কর্নার মানে রেঞ্জ দিয়ে লাইন ড্র করব সেই লাইনের
ইমেজটা
রেঞ্জ যে অ্যাঙ্গেলটা কভার থেকে মিররের এজ একটা লাইন ড্র করব
Yes, look, for that you just join the image with the ends of the mirror. So this is the image tracing that I was talking about, that from where I can see the image, that is very important. If this is the image and this is the object, then you can see that the image is a virtual in nature. Can you say that? Image is virtual in nature. Why it is virtual? You cannot touch that image, right? It is opposite side of the mirror. whatever world lies on the opposite side of the mirror is a virtual world, right? You cannot touch it, right? You cannot see that image without this mirror. Virtual world only exists when as long as the mirror exists, right? তুমি যদি মিররটাকে সরিয়ে নাও, there is no existence of the virtual world, only the object will be there. So if you are looking from here, actually the ray is not able to come to you after the mirror, because this ray is the boundary ray, right? This ray is the boundary ray here. So these limiting rays actually form this field of view. This is the field of view. If you place your eye anywhere in between those limiting rays, you can see the image. Suppose this eye, how this eye can see the image? The image cannot directly send the ray to the eye, but object can send a ray that is reflected and come back to the eye. And as our eye cannot retrace the light in a curved path, we only see the image to be lying here. But here or here, can you find any ray? Image cannot send direct ray to the eye, and the object is also unable to send ray because there is no mirror. So can you see the image from here? No.
Yes.
We cannot see image from here. So how to find the field of view? Field of view, very easy. Join ends of mirror with image. Join the ends of mirror with the image and you will find the field of view. Have you got it?
Field of view basically angle or length.
Field of view is not any angle or length, it is a region, right? No one is asking you to find the field of view, right? They can ask you the angle if it is a plane. It may be a cone, it may be a solid angle, right? It may be a space, right? But it is needed only to understand whether I will be able to see the image or not.
So can you explain this part again?
Field of view.
Yes, sir.
If this is object and this is image, where from you can see the image of the object, that is the field of view. If your eye is here, you can see the image because the object there is a ray that is reflected from the mirror and comes back to your eye. But if your eye is here, you cannot see the image. Why? Because from object there cannot be any ray that is reflected to the mirror from the mirror, because there is no mirror lying here. And image cannot directly send you a ray because this image is virtual, right? So you cannot see the image here from here. So how do I know from where what is the range? If I place my eye, I will be able to see the image. You just join the image with the ends of the mirror, because no mirror, no image. So I join the ends of the mirror and you will find these two lines, they are limiting rays. Limiting rays means the last ray that is reflected from the mirror can be this one, and here it is this side, this one. After that there is no ray that can be reflected from the mirror. So in between these two rays lies your field of view. Anywhere you place your eye, you will be able to see the image. Clear this one?
Yes.
So I have given you the coordinate of an object O. You have to just find me what is the coordinate of the image I. The mirror is inclined at 30-degree angle with x-axis. Suppose this is the coordinate axis. It is my mirror. There lies my object. What I will do, I will extend this mirror in this direction. Imaginary. There is no mirror here. And I will drop a perpendicular from object to the extension line. And I will go by the same extent. And I will find my image here. Yes or no?
স্যার দুটাই তো -3/2 আসছে।
দেখে নিচ্ছি দাঁড়া।
হ্যাঁ দুটাই -3/2
It is 30 degree. Mirror is here, right? There is no mirror here. But again, my formula is true for everywhere. Whether there is mirror or not, I will drop a perpendicular from the extended line of the mirror. Now you can see this angle is 90 degree, this angle is 90 degree. This is a triangle actually. Two triangles you have got. If you join here like this, these two are the congruent triangle, yes or no? This length is this length is common, and this is the two angles are also same. So if I say that this length is √3, can I say this length is also √3? And if this angle is 30 degree, this angle is also 30 degree. Can I say this angle is 60 degree? So the x coordinate will be √3 cos 60 degree and y coordinate will be √3 sin 60 degree. Right? So minus √3 cos 60 degree, comma, minus √3 sin 60 degree. That will be my answer. Cos 60 degree is half, so minus √3/2, comma, sin 60 degree is √3/2 minus 3/2. That is the answer of this question. Two large plane mirrors OM and ON are arranged at 150 degree. P is the point object, SS prime a long line perpendicular to OP. Find the length of the part of the SS prime on which two images of the point object can be seen. Try to do it. Let us consider only one mirror first. You can see that this point P lies somewhere here. Right? So after reflection, if I take this as a reflection from point P, one ray hits at this point. Can you tell me what is the angle of incidence here?
90 degree.
90 degree. 90 degree.
15 degree angle of incidence.
Yes sir.
Angle of incidence is 15 degree. If you drop a perpendicular, then you will find this angle is 15 degree. So after angle of incidence, the ray will also come at 15 degree. Can I say it is the limiting ray in this side?
Yes.
Right? And in above there is plenty of side. You can say at infinity the field of view lies. But field of view starts from here. Yes or no?
Yes.
Similarly, for the other mirror, can I say it will be from here to below? For this object P, the field of view will be from here to here, and for this object the field of view will be from here to here for other mirror. Yes or no? So this length is needed where from both the images will be seen.
Sir, it will be 2D tan 30 degree.
Yes, you can say it is D. This angle is theta, which is 30 degree.
30 degree.
So this is D tan 30 degree. So the answer is 2D tan 30 degree. Yes. Yes, someone said 2D by root 3. Yes, that is the correct answer. Have you got it?
মানে দুটো ইমেজকে দেখতে গেলে ওইটুকু জায়গাতেই থাকতে হবে।
এর ভেতরেই থাকতে হবে, তাহলে তুমি দুটো ইমেজ একসঙ্গে দেখতে পাবে। এর বাইরে গেলে তুমি 1 দেখতে পাবে না, আর এর বাইরে গেলে তুমি 2 ইমেজ দেখতে পাবে।
ঠিক আছে।
Have you got it?
Yes, sir.
So field of view is very important. In this way you can find from where you will be able to see the image.
Sir, actually I was stuck in that part that I was joining the image to the end lines of the mirror, but since mirror this length was not known, so I was thinking how can I calculate? হ্যাঁ স্যার, এটা আমিও করছিলাম।
That is a long mirror, and the above portion is not needed actually.
না, নিচেরটাতে মানে ওই পিঠে যখন শিফট করবে তখন কি হবে এটা একটু বলতে পারবেন? মানে
কোনটা শিফট করবে?
যে পিঠে ওই লাইন ও আর ও লাইন বরাবর শিফট করবে, তাহলে ইমেজটা কিভাবে শিফট হয়ে যাচ্ছে এই ফিল্ড অফ ভিউ?
পি যদি ওই লাইন বরাবর মুভ করে তাহলে ফিল্ড অফ ভিউ কি চেঞ্জ হবে?
না, ওটা তো ইন্ডিপেন্ডেন্ট অফ ডিসটেন্স অফ দ্যাট
ওই ডিসটেন্সের উপর চেঞ্জ হবে না, তোমার লিমিটিং রে ওটাই থাকবে, যেটা ছিল সেটাই থাকবে।
ইমেজটা কি ওই রে বরাবর শিফট করবে, মানে ওই along the limiting ray?
হ্যাঁ, ইমেজ তুমি যদি ওই দিক থেকে তাকাও তাহলে ওইখানেই দেখবে। যেখান থেকে তুমি তাকাবে ইমেজ ডিপেন্ড করছে কোন এটা ইমেজ ওই পয়েন্টে থাকবে। তুমি যদি এইখানে ইমেজ বানাও তাহলে ইমেজ কোথায় থাকবে এই অবজেক্টের? ড্রপ পারপেন্ডিকুলার of image will lie here, right? And this is the ray that we have drawn. This is the ray that we have drawn after reflection. This is the ray we have drawn.
তাহলে তো ইমেজটা এই রে along this রে ওই শিফট করবে যদি আমি ওটাকে শিফট করি।
এই ওটাকে তুমি যদি কোথায় শিফট করো? এদিকে
ওই লাইন along। হ্যাঁ
হ্যাঁ হ্যাঁ, ইমেজ তাহলে এখানে চলে আসবে।
না, ফিল্ড অফ ভিশন তো আনচেঞ্জ থাকবে।
ফিল্ড অফ ভিউ আনচেঞ্জ থাকবে, ইয়েস। ইমেজ এখানে চলে আসবে কিন্তু এই লাইনটা থিম সেম থাকবে। চলো এই কোশ্চেন কি বলছে? আ পয়েন্ট অবজেক্ট ও ইজ কেপ্ট ইন ফ্রন্ট অফ আ প্লেন মিরর AB, kept in front of a plane mirror AB having length equal to 2 meter. AB has a length 2 meter. Angle AOM, the line AOM makes 60 degree with the mirror. Observer is walking along the line X prime XM. Find the length of the path XM X prime in which he can see the image of the object. Given AO is equal to D equal to 1 meter and AM is equal to 2D. Okay, you can try this question as your homework. Okay, I'll leave this for your homework. A very similar type of question I think just we have done. Now that is very easy. I is a ray incident on a plane mirror, keeping the incident ray fixed. If the mirror is rotated by angle theta about an axis passing through O perpendicular to the plane, so that the refracted ray It's not refracted ray, it will be reflected ray. Right? Reflected ray rotates through 2 theta. Now, does your answer differ if the mirror is rotated about an axis passing through point B?
No.
Yes. What should be my proof? If I say that, let us try to prove this first. Suppose this is the mirror and this was the red color line. It is the incident ray. Now I am making incident ray fixed. Incident ray is fixed. I am not changing the incident ray. But I have changed the mirror, rotated the mirror about this point. Right? So about this point, if I rotated the mirror will be somewhere like something like this right now.
স্যার আপনি যে পয়েন্টের অ্যাবাউটই যদি রোটেট করেন থিটা, ওটা তো ওখানে অমনি হবে।
কোন পয়েন্টের অ্যাবাউটে যদি আমি
থিটা আপনি রোটেট করেন তো অ্যাঙ্গেলটা ইনসিডেন্ট রের সাথে তো মিররটা অমনি বানাবে।
যদি আমি এই পয়েন্টের অ্যাবাউটে রোটেট করাই,
হ্যাঁ মানে নরমালটা সেমি রোটেট করবে,
সেম রোটেট করবে, ঠিক। But here we will always measure the angle from a fixed line. So here the fixed line is this incident ray. Right? Fixed line is the incident ray. What is the angle between the incident and reflected ray in the first case?
Theta. 2 theta.
2 theta. The angle between this incident ray and this reflected ray is 2 theta in the first case.
স্যার 2 থিটা না ধরে আলফা করে দিন, কেন কি
আচ্ছা
থিটা রোটেট করিয়েছি।
ঠিক আছে, চলো কোনো ব্যাপার না। Let us assume it, the angle between them is say 2 alpha or 2 phi. Right? So this is now fixed. This angle will also change after I make this rotation by angle theta. After I make this rotation by angle theta, now this will be my
rotated by theta.
Yes.
Yes sir.
This will be my new reflected ray, right? Now the reflected ray comes here and it reflects back from this line, and this is my new reflected ray, right? So what will be this change that I have to find? What will be this change? This change.
2 alpha minus 2 theta. 2 phi minus 2 theta.
Look, if I say that if this is fixed line,
draw the normal of the new line.
We can do it in a very simple way. By drawing normal we can do it, but again by drawing from this line we can do it, I think, because look, initially the angle from this fixed line to this reflected ray 1 was 2 phi, right? And the angle between that reflected ray and the mirror has now changed by angle theta. Right? Okay, let us do it by normal only. It will be much easier, I think. So the normal of the mirror will also change by angle theta, yes or no? Now the normal of the mirror will also change by angle theta. So initially this angle was phi, and now this angle is how much?
Phi minus theta.
So this angle is also phi minus theta, right? So now the angle from this fixed line to this reflected ray 2 is 2 phi minus 2 theta. whereas initially it was 2 phi. So how much angle the reflected ray has changed?
2 theta.
This is equal to 2 theta, right? So it will rotate through angle 2 theta. That from simple geometry you can find, right? And as it is a rigid body, you rotate about any point, the normal will also rotate by the same angle theta. So it does not matter whether the point axis of rotation passes through A or B, right? It is the same angle theta it will rotate.